Hello everyone, today we are going to talk about the breadth first search algorithm, an algorithm to traverse graphs. The breadth first search algorithm, or BFS, is a graph traversal algorithm that, starting from a given source vertex, visits all vertices that are connected to this vertex, traverses the graph level by level. We will see this later in an example, and this is usually implemented as an iterative algorithm that uses a FIFO queue to store the vertices that will be visited. So the first element that gets into this queue is the first that will get out to be processed. This provides the paths of minimum distance in terms of the number of edges, and we are going to use here, to avoid loops, a set called visited. Let's take a look at the algorithm in Python. Here we have the dictionary of distances that will store the distance from the source vertex to any other vertex in the graph. We have the dictionary of predecessors that will store the predecessors of the nodes to recover the paths. We have here the queue that we are going to use to order the elements in order to be processed. The visited set, where we are including now here the source vertex, and we mark this as visited already, and we start including this source vertex also in the queue. While we have elements in this queue, we can remove the first element in a FIFO way, and we can iterate over the edges in this node. If these are not visited, we can update the distance to this node. We can include the predecessor, the current node, the node that we have extracted here is the predecessor of this node that is connected. We mark this node as visited and we include it into the queue. When this algorithm has finished, we have the distances and the predecessors in order to recover the path. Let's see an example here of the execution of this algorithm using this directed graph. We can start with the node A. We can include this in the queue, and as this is the first node, we can process this node, iterating over the connected nodes. We have here that A is adjacent to B, C, and G, so we can include this in the queue. Now B is in the first position to be processed. We can process B. Processing B, we mark B as visited, and this involves including F, that is the adjacent to B. So F now is in the last position of the queue. We have C in the first position, and we process C. From C we can get to D. We can include D in the queue. Now we have G in the first position. G has no neighbors, so we are not including new elements in the queue. Now we can process F, that is the following node in the FIFO order. From F we can go to H, so we can include H. We are not including B because B is already visited, so we include H here. Now D is in the first position of the queue. From D we can go to E and G, but G is already visited, so we are only including E in the queue. Now H is in the first position. We visit H and then we visit E. We have visited all nodes, and after running this algorithm we have a classification of the nodes regarding the distance in the number, considering the number of edges from the source vertex, that is the node A. We have the nodes that are one edge away from A, that are B, C, and A and G. The nodes that are two edges away from A that are F and D, and the nodes that are in at a distance of three edges, H and E. Thanks for watching and see you in the next video.